All right, so this is lesson 5.2, which is the same lesson as 5.1. What was the lesson in 5.1? Was on what's called optimization. These are questions that will ask you for the greatest or the least. Questions that will ask you for the maximum or the local, right, or the minimum. This is a word problem, but ultimately what you're finding is a local maximum or a local minimum that fits the problem. In our last unit, we know, how do you find a local maximum? How do you find a local minimum? Is you take the derivative equal to 0 and test on a number line to see if it's a max or minimum, right? Sometimes a derivative will have a value that's undefined. That also needs to be on your number line. So, can we read this one together? The challenge, right, is that you're not given the equation. Doesn't that suck? Like, it doesn't just give it to you to take the derivative. Wouldn't it be easier just to, here's the equation, take the derivative? Well, of course. So 99% of the problem here is just coming up with the stinky equations, right? Once you get to derivatives and number lines, well, that's easy stuff. Can we read together? Do you believe? Will you persevere? Yes. All right. So, the sum of two non-negative numbers is 30. I think the word sum means something. Maybe. And 30. It says, and non-negative means it's a fancy word for what? But it could also include 0. So, non-negative, right, means that 0 is included. So if they just said two positive numbers, 0 is not included. You're listening? Non-negative means it's 0 and positive numbers. So it's a fancy way to say 0 could be an answer. Because 0 is not negative. Yay? Yay. If you just said two positive numbers, then 0 couldn't be an answer. Okay. It says find both numbers, again the fancy word, sum of twice the first plus the square, man these are mathy words, right, is a what? Maximum. We got this. Hi Mr. Ortiz, leader of the football team. All right, Daniela and Francisca, these are for you. So, hey, where do we need to start? Let's get two letters. What letters do you love in math? Let's do it. Let's say x is the first number, or number, and let's say y is the second number. Is that okay? Write an equation from the first sentence. I like that. That is not complicated, correct? The first sentence, can you see x plus y equals 30? How about the second one? So it says the sum of twice the first. And we said the first is, so it's twice the first would be 2x. So twice the first plus the square of the second is a maximum. So we just need to make this an equation. It doesn't really matter what you make it equal to, but we need another letter. M, I heard it. M, because we want it to be a maximum. Now, which one is your primary? Which one is your secondary? The second one is your primary. The first one is your secondary. You have a choice to make. It doesn't matter what the choice necessarily is, but I'll tell you one will probably be easier to take the derivative than the other. But go ahead, think. Will I go x equals or will I go y equals? Will you get the same answer both ways? Yay! I agree. So which one do you want to do? Okay, so what does x equal? 30 minus y. So where there's an x, what am I going to put in? We good, right? Next. What do I tell you? What do I tell you? Algebra before the calculus. So that would be what?
60 minus y plus y squared.
2y. We're going to distribute.
Yes, 2y.
Okay, now can we take the derivative? Okay, go for it. Tell me what m prime equals. What is it? What? Yes, I agree. But if I went in order, right, that feels confusing in my brain. The derivative of 60 is 0. The derivative of negative 2y is, and the derivative of y squared is 2y. So yes, you're right. For some reason, I just wanted to go in order. And then you're going to make it equal to?
0. Y equals negative 1.
So what does y equal?
1.
Okay. Now what? Okay. It does. What do you think the domain for y is? To what number? 30. If I plug in 30 for y, right? 30 take away 30 is 0, which is okay. But if you plug in any number bigger than 30, what's going to happen to x? Okay. What number are you going to plug into the derivative?
0.5.
So if you plug in a half, what happens? Positive or negative?
Negative.
If I plug in 1/2 for y, 2 times a half,
1.
and negative 2 plus 1, this is going to be what? Plug in a number bigger than 1, but less than 30. What did it create? And what does the question ask? I quit. No. That did not answer my question, did it? So, because we persevere and we believe, we're now going to go in the other direction. Meaning, we're now going to solve for y and go through the process again. Because this did not give me the answer. I was not looking for a minimum, I was looking for a maximum. So right now we have a minimum. So the minimum would be if y was equal to 1, right? That means x would be 29, right? And that would give me a minimum, correct? Okay, here we go. Let's do it. Yes, I let you go there. So, let's come back here.
So you have to try both before you say
You have to try to make sure it answers the question, right? And if it didn't answer the question, go back, right? Go a different direction. So, instead of x, now we're going to solve for, instead of solving for x, we're going to solve for y. What does y equal? What did I tell you to do? Do you really have to do the algebra in this case? Will it make it easier? Let's take the derivative without doing the algebra first. What would happen? What would m prime equal? Derivative of 2x is 2. And how would you take the derivative of the second one? What would it be?
2 times the quantity of 1, negative 1.
And then, right? That'd be 1. And then the derivative of 30 subtract x is negative 1. So if I cleaned this up, what would it look like? So negative 1 times 2 is negative 2. And we know we're making it equal to 0. Keep cleaning it up. What do you get? Negative 1 times 2 is negative 2. Distribute. Negative 2 times 30 is negative, and negative 2 times negative 1 is positive 2x. Keep solving it, please. Now it's just a simple linear. How would you get 2x by itself? What would you do? 2 subtract 60 is, and if you add it to the other side, It was negative 58, but if you add it to the other side, it's now positive 58, correct? Divide by 2 and you get what? Okay, guess what? X, the domain again goes from, for this, it goes from 0 to 30, but what are we testing out? Now, do you remember where the derivative is again? We can still use this one right here, or even this one right here. And if we wanted to make it even simpler, the derivative was 2 subtract 60 is negative 58 plus 2x, right? If I wanted to make it, because don't you want it simple to plug in with your brain? If you plugged in positive 1, is the derivative positive or negative? If you plugged in any number here, what would that answer be? Positive or negative? Negative. Yay. And what would happen if you plugged in this? So if you plugged in 29 and a half, it would give you a positive answer. Is there any answer that gives you a minimum?
Maximum.
A maximum. Oh, you know what I didn't create? Do you know what I didn't test?
The second.
So, what we didn't test are the ends.
Yeah, I think 0 could
0 could be an answer, right? So, if I plug in 0, and by the way, if one is 0, the other is 30, right? So we have two options when we plug in 0. It's either going to be 0, 30, or the other option is going to be 30, 0. Which one there creates a minimum or a maximum? So remember, what was the equation again? It was 2x plus y squared. Which one do you think will give you a bigger number? The 0, 30? And what answer do you get? And if I went the other way, what answer would you get? So the question is, find both numbers, right? If the sum and so on, that would give you a maximum value. So what two numbers would I plug in to give me a maximum value? I want you to think here that when you plug in 0, the answers decrease, correct? To what number? 29, and then they increase a little from there. So what we did was tested out the ends. Will the left end or the right end give me a maximum answer? This here will give me the lowest answer. But here, right, gives me the biggest answer. So we can't forget about the end points, about finding it.
Like, so do we have to do all that stuff we did, like double, like look for x and y?
Right.
Yes.
Yes. And so the question was, what values for x and y should we use? So in this case, x should equal 0 and y should equal 30. That gives you a maximum value. What would give you a minimum value? The minimum value is when x was, right? And we would have to plug that in, and we would have to do the other one too, right? But it didn't ask for that. If our answer isn't in the middle, right? Notice the middle was a minimum. That means the ends have to be max because it decreased, right, to get there. That means the ends had to be high up, right, to come down to that point. But here's a different way to look at it, right? All right. So you have practiced this